Hi, and welcome to another video. Just going to look at this question here of Stack Overflow. Some guy asks if some guy called Greedo, great name, Greedo. Um, he wants to use something from .NET. Well, he's already using something from he's already using .NET interop. He has a project with a tools reference to this, which is the .NET runtime, and he uses this to sort. And he says, I think he says, look, I'm using an array of this, and this is perfect, and I implement iComparable, and I can call sort. However, I can't find a filter. So, and then he gives a few links, but those turned out to be not correct. So basically, this guy wants a .NET. He wants something. He still wants programming VBA. He still wants classes in VBA. And he wants to be able to sort those classes using .NET technology, and also he wants to filter, and the implication is that, well, he's happy to use other .NET technology as well. So so that's the brief: sorting and filtering in VBA, but leveraging .NET technology. So I'm going to start. Let's just get Excel. So I'm going to give you a run through the solution first. So let's just go here. Let's see what it looks like. And then I'll show you the C++ code, which makes it, sorry, the C# code, which makes it work. So I have a list of, I've invented a class. The class is defined in C#. This is just a list of integers. So the list class is in C#. The items, because they're integers, there's no class. For the questioner, the item class is going to be in VBA, but I'm going to offer him a solution where the list is going to be in C#. Let's just look at this. Let's just see if this does what we want. So you can see that we're going to populate a list with some integers, and then we're going to press sort. So these should print out in a different sequence. Should print out 2, 3, 7, 8. Let's just see. Watch the console. Watch the immediate window. Good. Now, so sorting, that works fine for integers. Now, what we're going to do here is we've implemented a lambda expression, a lambda function, and actually there's two of them. So we've got two levels of filtering going on here. So the first level of filtering, this lambda function, it says, well, if is x less than 5, and if so, let it through. So we have done this list of 2, 3, 7, 8. Only 2 should get through that. That would be 2 and 3. And then the next level of filtering, we say, oh, okay, well, fine. But what happens? I want the even numbers here. So what we have here, this is a C# expression, because this will run on C#. So this is a C# expression. So this is modulus 2. So that gives you that will only let even numbers through. So after those two levels of filtering, we'd expect, so 2 and 3 gets through the first level of filtering, and then the second level of filtering, only 2 gets through because 3 is not even. So we would expect, and watch down here for the immediate window, we would expect that to just print 2, and it does. Good. Let's go on, just to prove that we can do other types of primitives. So that was a primitive case. This is a second primitive. So we have test doubles. It's pretty much the same thing. Let's just go through this. 2 and then some decimals, blah, blah, blah. Let's just clear the immediate window. We sorted it. They should appear in sorted order, and they do. Good. Again, we have, we're going to use the same lambda expression from the first example. So we're expecting only 2 of those to come through. That would be 2 and 3.2. So let's just go down. Good. Excellent. Very good. Okay, so that's primitives done. But the question says he has a class. He didn't actually give a class, so I had to invent my own class here. So let's just talk about this class. This is a Cartesian point, so this is like x, y coordinates. And so that's why we have x, y here. And so you set it. I haven't bothered with some property setters here or property getters. But obviously in production you would do something like that. You'd use property procedures. But I just wanted to get the magnitude out. So if these are Cartesian coordinates, then obviously you have polar coordinates, and the magnitude is the it's like Pythagoras. You take the square root of the other two sides of the triangle. So 3, 4, 5. So if x was 3 and y was 4, the magnitude, the length of the third side would be 5. So that would be magnitude. And the other thing about polar coordinates, you get the magnitude, but also you get the angle. So the angle is given by this, but that's in radians, and it's not terribly happy. So we want angles in degrees. So that's that. That is in essence, it's simple. Oh yeah, so we need to find pi at the beginning to make this fly. That's very, very simple. What the rest of it, well, actually we'll come to that later, but a lot of it's just a boilerplate to make the thing fly. But if we just go over to the test module for this, I just want to show you that, we just got some. So there's the magnitude. So 3, 4, 5 triangles. So if x is 3 and y is 4, then you get the hypotenuse is 5. And here, what we're doing is, if we give x is the square root of 3 over 2, then that's a well-known trigonometric value, and that will give you magnitude 1, where y is a half, and the angle is 30 degrees. And then we just and then we go around a circle. So the point is, okay, that's fine. So basically, that's your you got the angle in degrees and you got the magnitude. That's fine. Now let's get back. So we want to take a list. So again, we have another list class defined in C#, and so a list of points, and we add points. So we have a Cartesian point here. I've given myself an array of 4. Actually, I only use 3. Change that. So I've got an array of 3, and then I just I set up the points, and then I add them here. So that's, and sorry, just for testing purposes, I'm just testing the magnitude here because I'm going to use the magnitude and logic lower down. So we just let's just run this. So it prints itself out as a pair of numbers, right, in brackets. So it's sorted there. So no, it hasn't sorted yet. So this is just the arrival sequence. You can see 3, 4 is at the front. But if we sort it and then print it out, you can see it printed it out there. That's fine. So now we can do the filtering. So here, a bit more of a complicated a Lambda expression. We're actually calling it a property on the object. And we're saying, right, why am I interested in those points when the magnitude is less than 1? So the 3, 4, 5 triangle, that will be excluded, but the other two, they're well below 1. So if we run the where, and then we print out, so we've only got 2 now. That's really good. And remember, we looked at the angle, and so we saw it goes around a full circle, but there's only one quadrant we're interested in, and that's where the angle is between 0 and 90. So that would be this number here. So if we run that, and then that should print out just 0.25, 0.5. So there you go. That is the VBA solution demonstrated. They're both sorting and filtering for both primitives and objects. And in the next section, I will show you the C# code. Okay, so it's time to look at some C# code now. If you look at this solution here, we have 2 projects. The main project is this LINQ in VBA. That is a class library that compiles to a DLL. Down here we have a test project. That is a WinForms project. I'm not going to show you that because that's part of the construction. That's just how I develop projects for VBA interop. I will attempt to mimic the cross-boundary communication between an external client and the core library by using WinForms, and then I will go on to use Excel as a client. There's no real benefit in me showing you the WinForms. So let's look at the class DLL, class library DLL, and there is only one main source code, source file in here, and that's lists and lambdas. And so now if you remember, we have class of integers, which is a class, so we have it here, and it's good programming practice in COM to define in fact you have to define the programming, the interface separately from the class. So we say we have this class, but it inherits us from this interface up here, and we have this attribute here which says COM default interface out of type this interface, and between this annotation, these annotations, we managed to convince Excel that it only has in fact one class, and the class implements all these methods. Whereas if you program in C# or C++, you'll be aware of the fact that the interface is in fact separately defined and from the class. But let's see what's on this interface. And we have the add, so we want to add items to our list of integers, and we have this toString, which is a quickie method to give a string representation. We'll need to know the count of the list, the length of the list. We need to have something to give us an item. As this is like an indexer, but we can't use indexes across the VBA interop boundary. So that's why we have item. Ordinarily you'd use square brackets. So between these two, we can write for next loops to say for x equals 0 to count -1, give me each item. So finally we have to sort as required by the questioner, but the real action takes place in this where method. The where method, so where is deliberately taken from the lexicon of LINQ, and where it is a filter function, and usually you pass in a lambda expression, but here we're taking actually a string. So let's go look at that. Well, let's go look at the class. This is fairly standard, so we'd given ourselves a list, a generic list of type integer in this case. Very, very easy, very simple. Everything we're just passing on to the list class. But the really interesting method is the where method. So what we have here is for each of the parameters we pass into the lambda expression, we have to supply a type, and because this is a list of integers, the type will be of type integer, and we pass that into this class called the lambda expression helper class, which we give it a lambda expression. We say we're expecting one argument, and we give it, say, the array of parameter types, which here we have one, we're expecting it to be of type integer, and what comes out of that class is a delegate. Now the delegate is not enough because we need to cast the delegate. So here we are casting the delegate because it's a list of integers. This has to be passed down here into the where, to the real where. This is the .NET where down here. We have to pass that in, and because we are expecting a list of integers, it's expecting a certain signature. It may be returning a bool, but it's expecting an integer as its input parameter. So we have to do this casting here, otherwise this won't compile. And here you see that the return result is in fact a brand new list, so we give ourselves a new instance of this list of integers, and then we set the list of the filtered, and then we return the new instance. So the magic takes place in this class here called the lambda expression helper class. Let's look at that, and it only has one. Method, and the top half of this is checking to see that the user has passed in a lambda expression, which makes sense. So we look for the arrow operator, and then we're expecting, and we split on the arrow operator, and then we're expecting two halves. We're expecting two halves. Yes, and then once we're happy with the fact we have two halves, then on the left-hand side has the arguments, so we will split the left-hand expression of the arrow, left of the arrow, and it will have left bracket, commas, and right bracket, and we remove anything that's empty. And then we make sure that we have same number of arguments as we expected. That's good. And the right hand expression, we say, okay, fine, let's just store that in this variable called expression, which gets used down here. I'll come to that in a minute. But we need to marshal. We need to create a list of parameters that get used, because when a lambda expression is sitting in C# code, then the compiler and the Visual Studio, they can supply a lot of contextual information, but if in the absence of that contextual information, we have to supply it. So we have to say, okay, look, x, when we say x is less than 5, we have to say, but x is an integer here, right? So, or long in VBA, it's the same as integers.net. So I give myself a for loop, even though there's only one. That helps for future, in case there's more than one argument. But we get ourselves the type, and we create, so we pass in the type to this expression, and the args here, that's just a name, so that'll be like x. Yeah, if you in another example over here, that's going to be like x. Now this was passed in parameterized. If you remember up here we have this. So because it's a list of integers, I know full well that these lambda expressions, which should be predicates, x should be an integer in this instance, so I can hard code it here. That's fine. So we create the parameter and we add it to the list, and then the list gets converted to an array here. And this is a magic line of code, and pass lambda. So here's the right hand side of the lambda expression, here's the left hand side, which gives you all the arguments, and at the end of it you get a delegate. Actually, no, there's one step before. You don't actually quite get a delegate. You get this thing called a lambda expression, and then we go compile. We say, okay, fine, that compiles it to a delegate. Now, there's to make this work, we had to do a little bit of extra work up above. So here we've got my alias, but this is a namespace. To make this work, you're going to need LINQ expressions. You're also going to need LINQ dynamic, but you need to, because of namespace clashes, you should give, say, using my alias equals system.link.dynamic for reasons better explained by some guy on Stack Overflow. Don't worry, this code works, but what you had to do also is with NuGet, you have to install this package here. Take the latest version, which for me is 1.0.7. So make sure you, if anything goes wrong, if you're trying to copy this code, make sure you look into this, because this is very important. Okay, so that line compiles to something called lambda expression, and we compile the lambda expression, and then if you remember, that gets returned up here, and then we have to cast it, and then once we've cast it to a correct signature, then we can pass it into the where, the real where, the .NET links where, and then we can say, okay, fine, it's a list, and that's it, and that's how we start off with a string, a lambda string. We compile the lambda string, and then we compile that lambda string to a lambda expression, and we can pass it into the where to give us a filtered list of integers, which is very, very good. And I'll just take a break before we make the next section. Okay, so I've set the Visual Studio project. Sorry, we must talk about some of the project properties. Actually, just let's stop this. Once you get into the guts of debugging the Excel VBA interop, then it's pretty useful when you set the startup project to be the DLL class, that you say, okay, fine, instantiate a copy of Excel and then open a workbook, and so the workbook is opened. So when I press start, it's going to open Excel, it's going to launch Excel, and it's going to open Excel. And incidentally, it's opening up on the right piece of code, because I have something here in this workbook that says application go to test object. This is a very nice piece of code to get to the right area. So, and actually, if we can just, I wonder if we can just put a breakpoint. Let's put a breakpoint in. here. So it comes down to here. Okay, so we're into this breakpoint. So we go in here. So here you can see, here's the lambda expression. It's well formed, so we expect it to work. So what we're saying is, so O is going to be of type point, the Cartesian point, because we said so here. And we just split it up, that's fine, lovely. And then split 0. First, the left hand side is just the arguments, the right hand side is the right hand side. And that's lovely, so the expression is here, that's fine. And then we just go create. For each parameter there's only one. We say okay, it's a Cartesian point. And its name O. It's a list. And there are no more. And we create the lambda, and then we compile lambda to delegate. And that's fine. And we can just step through. And that's pretty much all there is to say. So this works. I was very jubilant that it worked. You know, if you, the key point is, if you're going to have, the key point is you're going to have to define, you're going to have to, number one, you're going to have to define your list in C sharp. Number two, you're going to have to define enough information about the item in C sharp in order to make it work. If you're going to have a lambda expression on magnitude, you need to have this on your interface. Otherwise, .NET will not know enough information about how to call magnitude, and it will complain. It will say there's no such method called magnitude. So that's the advice. Yes, you need your list of points. You need a list. You'll definitely need your list in C# in order to make it work, in order to make it sort, and in order to make it filter with the where clause. And you will need to define enough information on an interface. But once you've done that, then you have free reign. So that's enough. I know that sounds a bit restrictive, what I told you, that you have to define the list in C# and you have to give an interface, but you really can do whatever the hell you want here, so long as you tell .NET enough information in order to make its half of the contract work. You can do whatever you want, and that's really powerful, because the whole point about VBA is that it allows, it's very much a tactical development technology. VBA it's there for users in order to create logic on the fly, and whereas the C# is, if it's compiled, it's compiled. You can't very well deploy a new version very easily. So there's a mixture here. The mixture is between C#, which is compiled, which is strategic, and VBA, which is tactical, and I think that's a pretty good combination. Thank you very much.